I'm going to be continuing my book, Mathematics: A Complete Introduction. I'm up to chapter 5, which is decimals. In this chapter, I will learn about place value in decimal numbers, how to convert between decimals and fractions, how to add and subtract decimals, how to multiply and divide decimals, and about terminating and recurring decimals. Introduction. The invention of decimal fractions, usually called simply decimals, was a gradual process. It started around the 12th century and was completed in 1585 when Simon Stevin, a Flemish scientist, published a treatment called La Disme, English title, The Art of Tenths. Stephen's symbolism was, however, very complicated. And although numbers written with a decimal point had first appeared in print in 1492, decimals were not generally adopted until the late 17th century. In fact, even today, the symbolism is not standardized. While the UK and US use decimal point, many European countries use a comma instead. Although Lord Randolph Churchill, Sir Winston's father, complained that he never could make out what those damned dots meant, the use of decimals brought many benefits, including making commercial processes easier, and in mathematics, the development of logarithms. I don't know what any of those things are. Place value. In chapter 1, you saw how in the decimal system, the place of a digit in a number tells you the value of that digit. The value of that digit in each of the first 3 columns is hundreds, tens, and units. Each value is 1/10 of the value on its left. You can continue this pattern to the right of the units column with column values of tenths, hundredths, and thousandths. The value of each digit is the value of each digit in the number 654.739, which is read as 654.739, is shown in the table. Okay. The decimal point acts as a marker which separates the whole number part from the part which is less than 1. For example, the value of the 7 is 7 over 10, and the value of the 9 is 9 over 1,000. The number 654.739 has 3 decimal places. The digit 7 is in the first decimal place, 3 is in the second decimal place, and 9 is in the third. With decimals which are less than 1, it is usual but not essential to write a 0 on the left of the decimal point. Thus, you write 0.53 rather than 0.53 to draw attention to the decimal point. If 2 decimal numbers have equal whole number parts, you can find which is larger by comparing their 10th digits, their 100th digits, and so on. For example, 4.23, which has a 10th digit of 2, is greater than 4.19, which has a 10th digit of 1. It does not matter that 4.19 has a greater 100th digit than 4.23. Example. Which decimal fraction is greater? 0.506 or 0.512? Start from the decimal point and work to the right. The 10th digits are equal. 0.506 has a 100th digit of 0, and 0.512 has a 100th digit of 1. As 1 is greater than 0, 0.512 is greater than 0.506. The symbol greater than means is greater than. For example, 5.2.1 shows that 0.512 is greater than 0.506. The symbol lesser than mean is less than. Thus, 0.506 is less than 0.512. Spotlight. It can be confusing to decide whether you should use greater or lesser or greater than between 2 numbers. Remember that the smaller end of the symbol points towards the smaller number. So 6 is smaller than 7, or 9 is bigger than 5. Or think of the symbol being an open mouth, which opens towards the greater amount. That's how I learned it. The alligator's trying to eat the bigger number. I remember that being a kid. All right, so chapter 5. I want to write down this though. So I like that table. So I'm going to copy it out again so that I can retain the information. So we got the hundredths, the tenths, the units, and then the decimal point. And then we have tenths, 100ths, and 1,000ths. So this is hundreds, This is tens, and this is units. This is a dot, and this is tenths, hundredths, and thousandths. So 654.739 would be 600ths, 5 tens, and 4 units, and then 7 tenths, 3 hundredths, and 9 thousandths. So this is actually 7 tenths. This is actually 3 100ths. And this is actually 9 1,000ths. Okay. This is chapter 5. Chapter 5. So let's do exercise 5.1. Question 1. A. Write these numbers in a table like that above, and in each case, state the value of the digit 3. Okay, well, I'm glad I did that. Okay. So it'd be 174.783, because this is 100ths, this is tens, this is units, this is tenths, this is 100ths, and this is 1,000ths. So the value of digit 3 is 3 1,000ths. B. So this is 100ths, this is tens, this is units, this is out of 10, this is out of 100, and this is out of 1,000. So it'd be 936.214. And the 3 is 30. Oops, B. Oops, okay, C. C. So 100ths, tens, ones, dot, tenths, hundredths, and 1,000. 10, 100. Okay, so then it's 400, 4 100ths, 72, and 3 2 9. So 3 would be 3 out of 10. 3 tenths. D. Okay, 500. 579.038. And then 3 would be 3 100. Number 2. Write down the value of the underlined digit in each of these decimal numbers. So that would be, A would be just 3. B would be 8 over 10. C, oh, I wonder if I have to, or 2 over 5. C would be 9 over 100. And D would be 1 over 100. 3. How many decimal places are there in the number 231.67? How many decimal places are there? 2. B, write down the digit which is in the second decimal place. 7. 4. How many decimal places are there in the number 0.609? B, write down the digit which is in the second decimal place. 0. Or am I supposed to do 7 over 100? 0 over 100? Could be either way. 5. Find the greater decimal fraction of each of these pairs. Okay. It is a 0.8999 or 0.901. So this one is bigger. B. 0.702 or 0.72. C. 0.01 or 0.009. This one's bigger. C. D. 0.101 or 0.909. This one's bigger. 6. Write down the largest number from this list. So we have 2.36, 5.362, 5.632, 5.236, or 3.625. It is 5.362 is the, no, 632, 632. Okay, 7. Write down the smallest number from this list. So it's at 0.786, 0.876, 0.678, 0.687, or 0.68. So it's 0.78, 0.678, 8. Write these numbers in order of size. Start with the smallest. Okay, so it would have to be 1 point something because it's 1.32, 1.302, 1.203, 2.31, or 1.23. So I'm just going to put a 0 at the end of these ones so that they're all the same. Okay, so I think it's going to be 1.203, and then 1.230, and then 1.302, and then 1.320, and then 2.31. That makes sense? And then next one, write down these numbers in order size starting with the smallest. So the same thing again, 9. 0.90, 0.910, 0.109, 0.901, 0.019. So it's going to be that one, 0.109. Then what would be the next smallest one? 0.109, and then 0.190, and then 0.109. No, that's there. Where am I? So I have 0. I got rid of that one. 109, 190. Okay, and then 0.901, and then 0.910. Number 10. Insert either greater or lesser than or greater than between each of these pairs of numbers to give a true statement. Okay, so 4.76 and then 6.47. That one is bigger. B, that's A. B, 5.72 or 5.27. This would be bigger. C, 0.39 or 0.4. Oh, 0. This would be, wait, 4 is bigger than 3. 4 is bigger than 3. D, 0.03 or 0.029. There we go. All right, let's go check my answers. 5.1, here we go. 3 1,000th, correct. 30, correct. 3 over 10, correct. 3 over 100, correct. A, 3, yes. 8 over 10, 9 over 100, 1 over 100. 2, yes. 7, yes. 3, 0. Which one? 5, which one is bigger? 0.9, 0.72, 0.001, 909. 5, 6, 3, 2, 0, 6, 7, 8. This is the order. 1.203, yes. 1.23, yes. 1.302, yes. 1.32, yes. 2.31. 0.1, 0.019, yes. 109, yes. 190, yes. 901, yes. 910, yes. Okay. 4.76 is less, yes. 5.72 is bigger, less, bigger. Perfect. All right. 5.3. Converting decimals to fractions. You can use place value or to convert decimals to fractions. For example, 0.07 equals 7 over 10 and 0.7 equals 7 tenths and 0.4 equals 4 tenths. The fraction 7 tenths is already in its simplest form, but you can simplify 4 over 10 to get 0.4, which is 2 over 5. You can extend this method to numbers such as 0.037 with 2 digits on the right of the decimal point. So 0.37 equals 3 tenths plus 7 tenths, which equals 31 hundredths plus 7 hundredths, which is 37 over 100. You can write decimals of this type straight down as hundredths. You should always give your final answer in its simplest form. The fraction 37 over 100 is already in its simplest form, but the simplest form can be a fraction with a denominator smaller than 100. For example, 0.45 equals 45 over 100, which is 9 over 20 in its simplest form. Similarly, numbers with 3 digits on the right of the decimal point may be written straight down as thousandths and then simplified if possible. For example, 0.139 equals 139 over 1000, which cannot be simplified. When you convert a decimal number greater than 100 to a mixed number, the whole number part stays the same, and you convert the decimal fraction to a fraction. For example, 5.3 equals 5/3 tenths. Oh, okay. So 0.37 is actually 37 100th, right? And 0.45 is actually 45 100ths, which is divided by 5 is 9 over 20. And then if you have a whole number, is 5 3 tenths. Okay, 5.4. Converting fractions to decimals. 1. If the fraction has a denominator which is 10, 100, or 1000, etc., you can use place value to convert the fraction directly to a decimal. For example, 7 100ths 27 100ths equals 0.27. Even if a fraction does not have 10 or 100 or 1,000 as its denominator, you can sometimes convert it to an equivalent fraction, which does. For example, 3 over 20 equals 15 over 100, which is 0.15. When you convert a mixed number to a decimal, the whole number part stays the same, and you convert the fraction to a decimal fraction. For example, 4 and 3/50ths equals 4 and 6/100ths, which is 4.06. The method you have met so far in this section apply only to fractions with a denominator of 10 or 100 or 1,000, or with denominators which is a factor of one of these numbers. Later in this chapter, you will meet a method which may be used to convert any fraction to a decimal. Okay. Exercise 5.2. Exercise 5.2, 1a. Convert each of these decimals to a fraction in its simplest form. So 0.6 is 6/10, which is divided by 2 is 3 over 5. B. Let's go down. B. Okay. So, sorry, I was moving the camera a lot there. 0 over 0.1 is actually 1 over 10. C. 0.48 equals 48 over 100, which is, say, divided by 2, something over 50. What over 50? 24 over 50? Let's get the old calculator out. 48 divided by 2 is 24 over 50. D. 0.39 is actually 39 over 100, which is, can you simplify that? I don't think so. DE. 0.09 is actually 9 over 100. 0.179 equals 179 over 1,000. G. 0.125 equals 125 over 1,000, which is, what if you divide it by 5? 125 divided by 5 is 25. Does 1,000 divide by 125? 8. Does that make sense? Oh. How can 0.25 also be 8? Riddle me that. 0.003 equals 3 over 1,000. Can I just look up that G? It's really weirding me out. 5.2, 1 over 8. One over 8. All right, 2. Convert each of the following to a mixed number with the fraction in its simplest form. So it would be 3 and 8 over 10, which is 3 and 4 over 5. B. 422 over 100, which is 4 and 11 over 50. C. 54 and 75 over 100, which is also 54 and 3 over 4. D. 23 and 48 over 100, which is also 23 and 24 over 50. Question 3. Convert each of the these fractions to a decimal. So 3 over 10 equals 0.3. That's A. B. 71 over 100 is 0.71. C. 7 over 100 equals 0.07. D. 387 over 1,000 is 0.387. E. 17 over 1,000 is 0.017. F. 9 over 1,000 is 0.009. G. 2 over 5 is 5 over 10, which is 0.5. No. Times 2 is 4.04. G. H. 19 over 20 is times 5 is what over 100? 19 times 5 is 95. So it's 95 over 100, which is 0.9. I. 17 over 25. Oops, 25, which is times 4 times 4. 17 times 4. 17 times 4 is 68 over 100, which is 0.68. Hij. 11 over 50, so it's times 2 equals 22 over 100, which is 0.22. K is 237 over 50. So can we divide it by, how do we do that? Oh, times 2. times 2 is 237 times 2 is 474 over 1,000, which is 0.474. L. 7 over 200 would be times 5, which would be 35 over 1,000, which is 0.007. Oh my God. 3, 5. Yeah, okay, 4. Convert each of these mixed numbers to a decimal. Okay. So it'd be 6. A would be 6.1. B. 9.03. C. 5.041. D. 1.45. E. 8 point, what's 8 times 4? 24? 8 times 4 is 32. 8 times 4 is 32. 8.32. F. What's 37 times 5? So it would be 12.185. Okay, let's look at the back. See if I got these right. So I'm on exercise 5.2. First answer is 3 over 5. Second answer, 1 over 10. 12 over 25. Oh, right, because you can divide that by 2 again, which is 12 over 25. 39 over 100. E, 9 over 100, 179 over 1,000, 1 over 8, 3 over 1,000. 3 and 4, 5, 4, 11, 50, 54, 3, 4, 23, 6 over 125. Go back to that one after. Point 0.03, 0.071, 0.07, 0.387, 0.017, 0.009, 0.04, 0.95, 0.68, 0.22, 0.0474, 0.35, 6.1, 9.03, 5.041, 1.45, 8.32, 12.185. Perfect. I need to go back and do 2D. 2D. Oh, because it's supposed to be 48 over 1,000, which is 23, and what's 48? 24 over 500, which I think is what the answer is supposed to be. 2D. 23 and 6 over 125. Oh, because I can keep going. 500 divided by 4 is 125. 23 and 6 over 125, which is what it is, right? Yes. Okay. Adding and subtracting. 5.5. How long have I been doing this? I feel like I've been here forever. Only half an hour. I'll keep going. Adding and subtracting. If you line up the decimal points and underneath each other, adding and subtracting decimals is very similar to adding and subtracting whole numbers. For example, with whole numbers, 354 plus 2,332 equals 2,786. With decimals, 3.54 plus 24.32 is 27.86. Example, work out 9.7 plus 683. So 9.7 and 6.83 equals 16.53. 24.4 plus 0.72, 12.4, 0.72, 13.12. 0.71, 6092, 71, 60, blah, blah, blah. Spotlight. You might find it helpful to put in zeros to the right of the last digit so that all the numbers have the same number of decimal places. For example, in example 5.51, part A, you can write 9.7 as 9.70, which helps you to align all the decimals. Example, 6.9 minus 2.4, 6.9 minus 2.4 is 4.5. 12.3 minus 4.7. 12.3 minus 4.7 equals 7.6. Okay, 19.04 minus 6.2, 19.04 minus 6.2 is 12.84. If the calculations are more difficult than those, you should use your calculator. Okay. 5.3. I love how it's just telling me, if it's harder than that, just use your calculator. So, exercise 1A. Work out the answers to the following questions. 3.2 plus 4.7, which is 3.2, I'll write it this way, plus 4.7 is 9 and 7.9. B, 8.6 plus 4.52 is 2 and 11 and 13.12. C, 9.82 plus 0.48, which is 10, which is 3 and 10.30. D, 23.8 plus 0.27, Soaps to 7, which is 7, 10, 24.07 E. 9.7 minus 3.4. So 7 minus 4 is 3, 9 minus 3 is 6.3. 24.3 minus 7.5, which is what? So that would be 23, and that would be 13. So that would be 8. 23 minus 7 is 14. G. 26.37 minus 19.2. I'm gonna put a 0 there. 7, 1, and then 26 minus 19 would be 5. No. 7. I went the other way. G. H. 32.4 minus 17.57, which would be, that'd be 1, that'd be 14, that'd be 13, and this would be 10, which is 3. 13 minus 5 is 8. 31 minus 17 would be 24. H. I. 6 plus 4.7 equals 10.7. J. 9 minus 6.8, which would be 8, and that would be 10, so that'd be 2 and 2.2. K. 12 minus 0.12, which would be 0, 0. So that'd be 11. This would be 9, and this would be 10. So it'd be 8, 8, 11.88. L. 7.9 minus 4.53. So add another 0 there. So this would be 8. This would be 10. So 7, 3, 6. It would be 2.37. M. 7.6 minus 3.749, so add zeros. Okay, so this would be 6, this would be 15, this would be 9, and this is 10. So 1, 5, 8, and then 3. MN. 3.86 minus 0.372. So this would be 7, 15, 10. So it'd be 8, 8, 4, and 2, because I forgot this is where it's coming from. Oh, 8.4 plus 3.685. So it'd be 5, 8, 10, which would be 12.085. Number 2. Work out the difference between 8.3 and 9.2. So 9.2 minus 8.43 is point what? 4 plus what is 7? 0.77. Number 3. The judges awarded a skater the score 5.8, 5.7, 6, 5.4, 6, and 5.9. Work out the skater's total score. So it's 5.8 plus 5.7 plus 6 plus 5.4. This is getting long. I'm going to do it over here. 3 So it's 5.8 plus 5.7 plus 6 plus 5.4 plus 6 plus 5.9. So 8 plus 7 plus 4 plus 9 is what? 28. And then 5, 10, 15, 20. 20 plus 12 is 36, 37, 38, 38.8. 4. Do it here. 4. The runner-up in a 100-meter race had a time of 10.37, which was 0.09 seconds behind the winner. What is the winner's time? 0.09 behind. No, behind. So we're asking what the winner is. Second place was 10, which means the winner was 0.09 seconds faster, which is what? That's what's asking. So it's 9, it's 2, that's 17, which is 8, 2, 9.28. All right, let's see if that is correct. Where am I? Exercise 5.3. 7.9, 13.12, 10.3, 24.07, 6.3, 14, F, 14.8. Apparently it's 16.8. 7.17, 14.85, 10.7, 2.2, 11.88, 3, 0.37. I don't understand, but okay. 3.815, 3.8488. I don't understand. 12.185. Where am I? No, it is right. 12.085. Oh my God. Okay. 0.77, 34.85. I did my math wrong. 9, 10.8. What? 10 point 10.28. I don't know how to minus things anymore, obviously. Anyway, I'm very tired. Thank you for joining me. I will be back on Friday to finish off the chapter. So thanks.